Very good. Okay, guess we can get started. So thanks to everybody for coming, braving the weather, even though classes are canceled. I appreciate you coming out here. Hopefully you drive back home safely. So let me start off by first saying my name's Dean Lee, and I'm in the physics department. But I would like to thank a lot of people who made this event possible. First and foremost, I'd like to thank Stephen Schechter, who arranged all this in the math department, and I also would thank the math department for co-sponsoring this event. I'd like to thank Arena Kogan and Evan Larkin for actually providing the keyboard and actually moving the keyboard from their home to here. I'd like to thank the physics department for co-sponsoring this event, also the University Honors Program, as well as Phi Beta Kappa for co-sponsoring. But I also very much appreciate the support of the faculty and students in the music department, the University Scholars Program. I know a lot of you are coming from there, and the College of PAMS, and to publicize this event, and actually many others. Now, let me tell you a little bit about Noam Elkies. So Noam is now a professor of mathematics at Harvard. He won the Putnam Mathematics Competition for college students at the age of 16. It was actually the first of 3 times that he's won it. And then he became, well, a lot of things happened, and then he got his doctorate from Harvard in mathematics at the age of 20. He studied with Benedict Gross and Barry Mazur. And then he became a full professor at Harvard at the age of 26. And that's the youngest ever in the history of Harvard, and still is. So Noam is well known for his work in number theory and related mathematical fields. He is actually quite well known for having disproved Euler's sum of powers conjecture for 4th powers. If you don't know what that is, go on to Wikipedia and look that up. He is also the current world record holder for the highest rank elliptic curve, and that rank is 28. If you don't know what that means, you can look that up in Wikipedia as well.
Or come to my talk yesterday.
Now, Noam is actually sort of a Renaissance man, though. He's obviously a pianist. He's a very good composer as well. And he's also a world-class chess problemist. He was the winner of the 1996 World Chess Solving Championship. Now, so Noam obviously has a very illustrious life history, but Noam is actually also a really spectacular person. I've known Noam since 1988, or 1989, when I was a freshman at Harvard. I met him in the Harvard Math Department when I was doing a lot of homework. And Noam at the time was a Harvard Junior Fellow. And over that time, and for the last 24 years or so, he's been a great friend. And when I think of Noam, I think of somebody who likes to think deeply of things. He has this sort of passion for understanding how things work. Basically, if something's interesting, if something's important, you might as well learn everything there is to know about that subject. That's sort of what Noam does. And I'm very honored to be his friend for such a long time. And I think you will be in for a nice treat. You'll have a very entertaining lecture here. You'll hear some piano, you'll hear some improvisation, and there's some surprises which I won't tell you before they happen. So let's welcome Noam.
Thank you very much, Dean, for great introduction and for inviting me here and putting together in only a space of basically a few weeks most of the people and support and materials that are going to make this possible. Also a pleasure to visit such a warm weather. I'm not kidding. Where I came from, I'm told that it's going down to 0 degrees today, Fahrenheit. So this is actually a welcome reprieve, believe it or not. As far as the topic of the talk, which Dean did not mention, I'm calling this canonical forms. Another person I have to thank who didn't tell me their name is the one who provided this pen. Canonical forms is a bit of a pun. Those who know me, including Dean, know that I have something of a weakness for puns and other wordplay. It's a term in mathematics whose meaning is, sort of, that's for a separate talk. But I'm using it to talk about the forms of musical canons. And a musical canon, in case you haven't heard one before, or at least haven't knowingly heard one, because you've all heard musical canons, is, well, here's a famous example. It goes something like this. Etc. And the thing that's interesting about this, besides the stupid human trick of producing 2 notes out of 1 vocal tract, is that not only are they 2 notes simultaneously, but it's actually the same melody. So the same thing that was happening down here, that happened a few seconds before up here. So bringing them a bit to close the register. So I'm playing the same melody, but instead of playing it together, I'm delaying the lower part by, what we call in music 2 measures, and so forth. And it actually works. It makes sense as a piece of music, and for a simple piece of music, but a piece of music nonetheless. And you could have actually done, could have had a third voice come in. I can't do it with just my vocal track, but I have 10 fingers, and I'm only looking for 4 notes, so I can certainly do 3, and then you could have a 5th voice come in, but we have reached the end of the tune, so the 5th voice will just repeat what will just be collided with what the 1st voice is doing. But it's actually a canon in 2, 3, or 4 parts. So canon in this, it means that you have the same melody being played or sung at, in this case, 4 different times, and it all makes sense, not just as a tune, but it also makes sense harmonically. And so this is the kind of musical structure that I propose to explore from my somewhat idiosyncratic point of view for the next hour or so, or what's left of it. Canons have been, the canons go back almost as far as Western music. Canons are a special case of counterpoint, and just to say, possibly different strands of music going on at the same time, and also making sense both as linear, as lines of music, and as harmony. And almost as long as we've had counterpoint in Western music, which is roughly going back to the age of Michaud, we've had canons. And canons can appear in very different musical contexts. They can have so there are various names for them. The reason that it's called a canon is, ask your favorite music historian to explain just what canon was originally and why it was written and why the red ink was used for the rubric, etc. But there are other names for it. So, for instance, what I just referred to, I usually think of as a round. Special simple kind of canon, which I'll explain later. There are also canons that are called catches or cachas, which suggest, what's happening here? Oh, that sort of works. So that's the Latin, the Italian, for catch, or the idea that you're imagining the second voice trying to run after the first one, so sort of this game, like the game of catch. So an example would be if you look at Mozart's 576th piece. Mozart, to paraphrase Tom Lehrer, is a rather sobering thought that Mozart, by the time he was my age, managed to write 22 operas, revolutionize the piano concerto, write like 20 quartets, and be dead for 10 years. And he wrote a total of over 600 pieces, counting a whole opera as a single piece. And one of the last ones is number 576 in the standard listing, and if you don't remember 576, remember 4 factorial squared. Some of the powerful numbers from 1 to 4 squared. That's a famous piano sonata in D major. Starts and so forth, or roughly something like that. And at some point, as he's moving to a different key, he gets, so remember, the main tune was this, and he starts playing with it as follows. Or at least that would be sort of, that would be what I might think of writing, except that's not exactly what Mozart does. He almost does this, but I've been playing the same tune in both hands at the same time. What he actually does is the left hand comes in 8 notes for just one, musical quantum, if you will, of time after the right hand. Or in something more like real time. So it has this effect of the left hand is trying to chase after the right hand, which is a lot more fun than just. So that's one kind of effect of the canon. It can also be more of a kind of conversation between two parts, each one of them, two voices, if you will, each one of them sort of echoing the other's thoughts and completing the other person's sentences. I'm told that Beethoven's Fourth Symphony was performed here a few days ago by the, what is it called, Triangle Area Symphony? At any rate, Beethoven's Fourth at one point has this tune in canon, which sounds something like. So it's more like the bottom, it's not that the bottom part is chasing after another, it's sort of this polite conversation. I say something, you say more or less the same thing. I'm completing your sentences as it were because I'm not letting you quite finish before going on to the next thoughts. It's not an impolite argument, it's this, it's this friendly conversation. And it doesn't have to be all that blatant as these examples. Each one was very clear, okay, the bassoon is doing whatever the flute was doing, just a measure later. So here's an example from a late piece by Brahms. I'll be coming back to Brahms every once in a while. Besides Bach, Brahms is probably the most famous for including canons in his music. But people, rather surprising people have done that also. You don't usually think of Shostakovich or Schubert as doing kind of very deliberate composition that would include putting canons in their music, but there are some remarkable canons even in Schubert and Chopin and Shostakovich and almost any other composer that you know. But the Brahms clarinet piano sonata at one point, so the clarinet is going to be the melody, everything else is going to be the piano part. The piano is sort of echoing what the clarinet is doing a bit later, but there's actually an exact canon there if you listen not just to the beautiful consonant harmony, but if you listen specifically for the bass part. So there's an exact canon. If I just take away everything else for a minute. Going on. actually at the, sort of at the bottom, near the bottom level of the structure of this. So, so we have all of these different kinds of canon, and there are others that I haven't shown you yet. Why do composers do this kind of thing? Well, so there's, the standard answer of why do we do anything difficult, partly because, the challenge is there. Why do people climb Mount Everest? Because, it's the highest point on Earth, and it's a natural challenge. How high can you get to? There is, to be sure, some component of showing off. Look at, what I can make this line of music do, but it can't be just showing off, because if you're going to show off, you're not going to hide it, right? Brahms constructed this beautiful canon, and then instead of, instead of saying, "Go guys, there's a canon here at the 12th," he makes it. You almost have to, ignore the music to find the canon. So it's not just a matter of showing off, and I think it's, to be sure, there is a matter of trying to overcome the challenge, but I think it's more a matter of, there are several ways of thinking about it. There is this, if you want to philosophize about music being, sort of an imitation of the voice, that's not philosophizing, but it's sort of like, aesthetic theory, or, trying to imagine the historical beginnings of music, etc. Well, polyphony is literally, at least it used to be that you didn't have instruments, it was just human voice, and it was several voices singing different tunes at once, but if the tune is representing some kind of musical character, then when you have a canon, you're hearing two different aspects of the same character. Here you're hearing this as both a tune and as a harmony. But, so it's very common in drama and movies, whatever, that you see different aspects of the same character, but this is the only way in which you can have the two characters, two or more aspects of the character being able to be heard at the same time and to communicate with each other, so to speak, with itself. So that's sort of an analogy, or sort of a way of thinking about it in terms of anthropomorphizing what you're hearing. But also it's a way of writing music organically. So it's having very exploring completely what you can do with a very limited set of building material. So I'll come back to this example later. I don't know, I won't even try to make it larger, but does this work? It's from one of Brahms's motets. This one is based on Psalm 51. And, oh, I don't have a second copy of this. That's okay. You don't have to actually read music notation to follow this talk. And so there's a 5-part chorus here. Sorry. So here there's this basic motif that shows up as the melody. There's all of these internal canons going on. But there's also this wonderful, more structural canon that's at the basis of it. If you look at the bottom part here, the bass is singing etc., which might sound familiar. It's almost what the main melody, the soprano, is singing, except that it's it's 2 octaves lower, so I can actually sing the whole thing, and it's twice as slow. So it's actually what we call a canon augmentation, and so again the same thing is being used in several different functions. It's being used as the as the main melody, it's being used as the bass twice as slow, and it's being used to generate some of the counter melodies, the the filling in of the texture. So I'll come back to this one, but this is going to be more of a catalog of just my favorite, some of my favorite canons. To be sure, I'm going to let you to play quite a few other examples of favorite canons, but it's also going to be a little, view under the hood, I guess it's called. I don't have a car, but behind the scenes look, let's say, to let you in on how one goes about composing one. Composing is literally putting together poneres, to put together. How one goes about putting together a canon, and to look at the structure of a canon. Some structures are easy enough, as it turns out, that you can make one up more or less on the spot, and I'm going to do that in a few minutes. And some of them are so hard to construct that you're only going to find a few examples in all of the standard literature. And I will do this at an abstract level that will apply equally for, it won't depend on musical style. It will work just as well for Frère Jacques as for Brahms, as for Bartok writing, the Diary of the Fly. Which is almost, somebody coming from the world of Bach and Brahms, it sounds almost like some kind of grotesque parody, but it's still it has its own musical, it makes sense in its own musical terms, and it's again a canon. One voice comes in here, the other voice, it's the same tune, just upside down. It's called the Diary of a Fly because it's supposed to sound like annoying buzzing pest and so forth, but it does go in a funny way, just like the mice in the cartoon are not the mice that you're trying to keep away from you so they won't pass on disease, and they're sort of this idealized fun version of mice, and these are idealized fun versions of flies that are realized with this canonical technique. So as I said, I'm going to do it at an abstract level that will apply to all of these, and that's for several reasons. One is I can't assume that everybody here is music notation. So I'm not going to use music notation, I'm going to use diagrams. So here is my diagram, my sort of summarized score of Frère Jacques. That's a two-part Frère Jacques, which is what I whistled and hummed at the beginning. Can this be seen at the back? It should say A, B, C, D. A, B, C, D here. Okay, I see somebody doing this in the back. Does this one look better? Okay, so how is this Frère Jacques? Well, it is basically music notation. Music notation, be it this, or be it what you see here, is basically a graph of events happening against time. So if you just look at the top part, it doesn't matter what's happening here. As far as the only thing you have to know is that time is proceeding along the horizontal axis. So whatever is happening on this line, all of these are going to happen at the same time, and these will happen a bit later, and these will happen a bit after that. So there's going to be two different lines because it's a two-part canon, and they're happening at the same time. So A is going to be the first thing that I whistled before I did the humming part, and then B is C, D, and so you see A, B, C, D is the whole tune. This is therefore the same tune, but by writing it in this fashion, I'm indicating that voice 2 is going to be coming in at the same time as voice A has gone on to B. So B will happen at the same time as A. So, and then C will coincide with, and D will coincide, and D, which is, will coincide with, I hope I got this right, previously C is that. So that's the score of the two-part canon of Frère Jacques, and it's also the score of any other two-part canon. So if I was doing Row Your Boat, that's A, this is B, that's C, that's D, and so the canon, first play A, then play B, C with D. And then if I kept going in the round, then A would happen at the same time again, and I'll keep going. So that's a two-part canon, and likewise a three-part canon would be the same thing, except there would be a third voice that would come in when voice 1 has reached C and voice 2 has reached B. And the four-part canon would be the same, except I add a fourth voice. And this notation also gives you, the sense of what the structure is that canon has to satisfy. So each one of these has to make sense of some kind of musical tune, right? It's just one musical tune, so just as A, B, C, D has to make sense. But also in the two-part canon, B and A have to make sense together as harmony, as do C and B, as do D and C, and if you're doing a round canon, also A. If you're repeating, it's also A and D. Likewise, for the three-part canon, A, B, C have to work together, and then B, C, D have to work together, etc. For four-part canon, all four of them have to work together. And again, this is an abstract version of the theory, so I'm not going to go into the details about what it means for B and A to go together. What it means, for what consonants means, that depends on the style of music you're in. It means something different for Bartok than it does for Brahms, than it does for Bach. But once you have set up the style, the language of music you're speaking, it makes sense to look for canons. And so that's a notation for this canon, but we can do the same thing for other kinds of canons. So for instance, for the Bartok one, which starts, that's A, bum, 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 bum. Then the second part doesn't quite do A, it goes A upside down, bum, 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 bum. So I guess it will have to look like this. And then C comes here. What's an upside down B? Well, it's a B again, but I made sure this part of the B is bigger than this part, so and I don't know. No. You get the idea, though. Have to look like this. Anyhow, so that's the Bartok. And so now you see that we have a notation that sort of abstracts out the questions of what exactly are the notes, how do I read this notation, what does it mean for two parts to be harmonious. It just sets out the structure of the task of what it means to write such a canon. Now, at this point, you might be thinking that this is looking less like music than like algebra. And well, once people hear some part of my background, in particular the fact that I've been involved all my life in both mathematics, which I might associate with things like this integral sign, and also with music, which you might possibly associate like the what do you call it, like the swirl of cookies that I'm told I missed at T upstairs, but which you might associate with this symbol. People often ask, well, we've already heard about relations between math and music. What's happening there? And truth be told, most of the relations that people try to draw are not much deeper than this visual one. But there are some cases, and this is one of them, where a scientific or mathematical way of thinking can help you see what's happening. And the very first thing you might ask if you're a scientist is, well, there's a null hypothesis. So the null hypothesis in this context is that there's nothing to explain. And there's nothing to explain because whatever I decided to put for A, B, C, and D, there would work as a canon. So any tune, so the null hypothesis is there's nothing to explain because any tune practically works as a set of the canon. So for example, here's another famous tune. see. So I play that. So this is going to be A, this is B, and this is A. That doesn't sound particularly good. I mean, we could try splitting it up differently. Maybe just the first half bar was A. I think, I mean, you can do this with almost any tune. This doesn't sound like a canon. I mean, yes, the right hand is playing something, the left hand is doing the same thing a bit later, but it don't make any musical sense, at least not in the kind of music that we're used to, together. It doesn't sound like a canon, it sounds like my left hand doesn't know what my right hand is doing. And I think it's pretty clear that the null hypothesis is not the correct explanation for how one constructs and understands canons. Now, the mathematician, you'd look at something like this, and you'd say, okay, that's a rather complicated set of conditions. Maybe there are some trivial solutions. Some easy way that always works, even though the trivial solution might not be all that interesting, is to at least give me some insight about what the structure is like. So here is probably the most trivial solution. So, it's a solution, I claim, of the task at least of making the vertical work. And that's assuming, remember, I haven't told you anything about counterpoint, about harmony. So you will have to allow me to play, the usual game of mathematician. I don't know what harmony is. To say anything reasonable about it, I have to assume some axioms. And the most obvious axiom is that it's a bit like an equivalence relation. It can't literally be an equivalence relation because, if A goes with B, that should be the same as B being, harmonic with A. That's almost true. I mean, there's stuff about fifths and fourths, different registers, but this is a very good approximation to the truth. And this is an even better approximation to the truth. Any tune can be played together with itself. You do it all the time when you have several violins playing the same melody, or a whole crowd of people singing, they're in harmony, but they're in trivial harmony with themselves. They're saying the same tune. So this is a trivial solution, but you might think, though, that's way too trivial. Nobody is going to write a canon like that, because who wants to hear this tune? Yeah, it's a canon, big deal. But musicians have learned, and composers have learned to do some things that sound quite interesting and are basically just that. So, for instance, instead of A just being the note A, it might be, maybe an A major chord. So I could be going up and down the same A major chord. And there are various tunes that are, familiar tunes that only go up and down a single major chord. And, when Shostakovich came to write his set of 24 pairs and fugues, the one in A major happens to be happens to use this as a theme. Now, if you have never heard the word fugue before, I'm not going to go on the whole exposition, no pun intended, what a fugue is, but I will, mention that the fugue, among other things, is a piece at whose climax there is almost always a canon, where, if at the very least, a voice is played with together with some, delay of itself, etc. So the left hand played, which is exactly what the right hand was doing. But basically, an A major chord, anything you play in A major chord, you're going with anything else you play in A major chord. So this is basically just this trivial, mathematically trivial A canon. And so forth. And of course, the thing that makes this piece interesting is not the fact that it's a canon, but that he managed to construct, a tune and a series of harmonies that make it appealing to listen to, even though when each individual theme is being, each individual iteration of the theme is being played, it's basically harmonically as simple as it could be, it's just one major chord. So that's one way that we can expand this into making a, something that sounds like a canon, but it's very simple. Another way is to interpret A instead of a single chord as a single sequence of chords. And then any tune that fits that can be made into a canon. How almost every round is constructed. So you start out with some simple harmonic progression, and then you find some tune that keeps going through this, but is sufficiently interesting that you can actually hear it as a musical tune and wait until the second part comes in to have all the harmony work out. And in fact, what I started out with today is an example. So of course it works in canon, because anytime I'm playing the same harmony, so of course it fits with itself, and it fits with the earlier version of itself, because the earlier version was the same harmony. This A was the same harmonically, was the same as this one, or rather, this C was exactly the same harmony as this B is exactly the same harmony as this C, and so of course they go together. And likewise, many other canons. So, for instance, Three Blind Mice, which is what I asked to put on the poster for this, is exactly the same chords. You might not realize that Three Blind Mice and Frère Jacques are basically the same music, but they're close enough that not only are they analyzed the same way, but because they're both the same, you can actually play them at the same time. Works out perfectly because it's the same harmony. And of course that means you can play them in canon at the same time. You can have one group playing, singing Frère Jacques in 2 or 3 or 4 part canon, and the other singing Three Blind Mice. And so for its own, it's a wonderful, double 4 part canon, but it's really just this. And that's again how basically every round works. Okay, so these are what we usually call rounds. I mentioned there are several various different names that are used for canons. There are patches, and there are rounds, and there are canons. The rounds are usually those that you recognize that these implicitly are, somewhat special, somewhat trivial case that falls here. Okay, so now let us try to throw away these trivial cases, although, I'll confess that even when a composer is putting together a rather non-trivial canon, they'll often resort to one of these constructions to get from, one part of the canon to another before something else interesting happens. There is, by the way, a variation of this idea, which you might have noticed that once you get to this point in the canon, if you have contrived somehow to make A, B, C, and D work together with each other as 4-part harmony, they will probably also work with each other when laid out this way. And likewise when laid out this way. And likewise, if you have a 3-part tune that you want to make into a recurring canon, right, so A has to work with B, A has to work with B and C and B have to work with A, but actually once you have gotten your 3-part counterpoint here, it probably also works this way, and it probably also works this way. And lots of familiar canons are basically, somebody found, wrote a 3-part counterpoint, then decided, okay, I'm going to choose some order of these 3 voices, write A, B, and C, declare that's a tune, and call that a 3-part canon. or 3-part round. So do and no fraction, which you might know. And so forth. Works the same way. It's a 3-part counterpoint. It's almost certainly not by Mozart. You might believe that the first part of it is by Mozart. Then the second part is a bit, a bit chancier. And then the third part is basically filler to work with the other two. And if it were Mozart, he was a good enough counterpoint writer to make each one of the 3 parts sound like a good piece of music, as opposed to just A, B, and O, something that works with A and B. But that is also known as a round. And so these are essentially the main trivial solutions. Have the same voice over and over, the same thing over and over again, maybe interpreted as a chord or a simple progression being repeated over and over, or you have a single piece of counterpoint which you then lay out as the 3 parts one after the other and declare that's a round. So ignoring those, let's see how we go about constructing a canon. And the basic degree of difficulty, if you will, of a canon is measured by how many parts it has. So for the full-fledged Frege or 3-blind mice, but 4-part canon, so this would be n equals 4. And if I had done it only with 3 voices, it would be n equals 3. And like many things in mathematics, these questions get more and more difficult and then increases. So what's the first n that I should consider?
2.
Okay, somebody's saying 2. Okay, so you've probably already made the first 2 steps. The smallest possible n, I suppose, is 0. But, well, here's a 0-part canon. Hope you enjoyed it. Those of you who are fans of John Cage might be satisfied at this point, but the rest of us want a bit more out of our music. What's a 1-part canon? Well, a 1-part canon is basically a tune. There is no harmony. There is just a matter of writing A, B, C, D, E, etc., and having it all, make sense of a musical tune. Writing a musical tune that is, that is coherent and makes musical sense is a non-trivial task, as anybody knows who has listened to, popular music these days, or listened to, beginning music students trying to write, trying to write some basic melody and harmony. But we have to assume that that's a solved problem, right? Because we're trying to put together, to have a general description of writing a canon. And if we're going to do that, we have to assume that we know how to write single voices of music. Just like we have to assume that we have some relation that tells you when 2 bits of music make sense with each other in harmony. So I'll assume that we already know how to do that. And then the first non-trivial case is n equals 2. Okay, so here's how almost everybody is going to write a 2-part canon. Whether they're Machot or Bach or Schubert or Shostakovich, if you're going to write a 2-part canon, we already know that you're not just going to go to your, the tune generating part of your musical brain, write some tune and hope that to work with itself in canon, because we know it usually won't. Instead, what you'll do is the following. Remember, 2-part canon looks like this. So supposing I want to make a 2-part canon which starts maybe with this snippet of music. That's going to be my A. Before I write a single note of B, I already know more about this chord than just this A. I know also that part 2 is going to have an A here. Maybe this I should do on a separate piece of paper because I'm going to need to make some kind of diagram here. So before I write this B, I'm going to write down the A in my music score twice, one diagonally below the other. And now I know that whatever this B is, besides continuing A as a tune, also has to work with A as harmony. So maybe, and once I have chosen that B, this B has to be here. Of course, if this makes sense of the tune, so that this A going to this B, and I just put that in my score before trying to make a C. And then the C, how do I find this, by the way? Well, again, this is what I'm assuming I know already how to do. I assume I know how to do counterpoint. So doing counterpoint means, you know, if you have one tune, you can fit another tune to it. So if you couldn't do that, then there would be no point in writing canon. There's no hope of writing canon because that's a special case. But if you know how to do counterpoint, then I claim you know how to do canons. Right? So then you have to find a C that continues this B. Right? So far we have gone here. So maybe this is C. And of course, this will continue in the same fashion. So maybe A, B, C, A, B and A, sorry, C and B, E. Right, so there's a problem here, which is that it's, right, so I had eight segments here. A, B, C, D, E, F, G, H. And the problem is, okay, I started this way, and then I reached H, and the second part was still on G, and to make it an exact canon, it just has to continue on to H, while the first voice was already, finished playing, or finished singing. Now, it's a common gesture in music for voices to come in one at a time. It's not nearly as common or usually as effective for voices to finish one at a time. Usually everybody finishes at the same time. You know, there's a big gesture, end of piece, clap, 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 or whoo, or whatever, or tune for the next movement. But you don't usually have a few people playing on when the rest of the orchestra has already stopped. Yeah, there are exceptions. There's the Farewell Symphony where, you know, all of the musicians except the first few violins go out trying to hint to the Count of Esterházy or whatever, that's about time for a vacation. But usually, you want everybody to finish at the same time, and almost anybody who is writing a canon will allow themselves the liberty of, well, first of all, dispensing with final H, and second, varying the thing just before it a bit, we might call it G prime, to something somewhat different, that acts a bit like G, but isn't obliged to go on and can complete the piece with H. So maybe instead of, or, that's not that exciting way to be. So the piece of, that's at least more conclusive then. So that would be H with G prime, and the whole canon then would be so it's not the best canon ever written, to be sure, but you can see it's more a straightforward procedure of constructing a piece of music, and I could have even done it. You know, I could have actually done it in real time, right? Because at any point I only have to remember what happened before, and you know, to think of what has to do with counterpoint at the same time. And to show that it can actually be done in real time, I'm going to do it. So I'm going to make up a canon like this one, except that I won't have prepared it in advance. Okay, how am I going to convince you that I'm going to do that? After all, if I just started the piano and said, let's see. Am I making this up? Did I write it before? Did I, go to some, Haydn 17th Symphony, which hopefully nobody else knows, and find a candidate and play it here? There's no way for you to know, at least not to know between the first two. And the only way that I know to do this is, what the people in cryptography would call a protocol. I prove that I can make a canon by making it a response and challenge, a challenge and response protocol. You give me the A. You tell me what I have to start with, and then I don't have a choice of, playing my own canon, unless I was extremely lucky and your A happened to match the canon I know already, or I was extremely devious and collaborate with somebody in the audience. So please, if you know me, don't propose a team. But otherwise, you give me the A, and I have to execute this in real time. So some of you, I don't know the audience, but is brave enough to hum or whistle or sing a few notes. Anybody? Yeah. Yeah. So this. Okay. This is a major chord, of course. So I have to watch out that it doesn't just sound like one of these AAA canons. I think I'll be able to get out of it. Let's see. Two-part canons are basically easy. I mean, you still have to make sure that as we keep going here, there are, how much time do I have, by the way? What time is it? About 4:50 minutes past. 4:55, wow, okay. So, I guess there are some things I won't be able to get to. One thing I mentioned is that, of course, the thing that you have to avoid besides getting into one of these AAA loops is having this situation where you keep doing this and it all makes sense locally and there's no, doesn't sound like a single piece of music. It sounds like I'm moving around. In other words, you have to have a bit of freedom left over from satisfying these constraints to make some kind of overall musical shape. And there are various tricks that composers use to do that. For example, that canon I played in the beginning, for Mozart, the interval is just one eighth note. So if I did my diagram here, A, B, C, D, right? A, B with A, C with B, D with C. So A, B, C, D, E, F, G, H, I, J, K, L, M, O, by the time I get to 6 measures, it's already double P or something. And Mozart didn't just do that one eighth note by one eighth note. So you can hear there's a bit of, there's a bit of this major chord which has to work with itself. So that gets us up to here. And then there's a scale. And once a scale, so a scale is a special case of what musicians call a sequence. So that's sort of, it's not quite A, but it is, A, and then A translated, heptatom, and then same thing down to septatom, tirom, tatom, etc. So once A works through the translation of itself, then applying the same translation twice, right? So here I guess the axiom will be if A works with B, then any translation of A works in the same way with the same translation of B. Right? That's a fancy way of saying if this canon works in A and C major, it will also work in G major, etc. So once I know that this works, because this is the same as this, just taken down a few steps, this has to work. Right? So that gets all the way from A up to whatever it is, somewhere around M, and then it does the same thing again. Oh, there's a bit of change here, but you only have to figure out one of these changes as opposed to 24. Right, so you see, we get almost to the end of the canon, and it's all of these, little sub things which individually are quite trivial, but you get to play this game of putting them together to make some kind of, right? So the whole thing is actually right. So there's this underlying harmony which the whole canon is superimposed on. Now, just to hit a few of the points after that, so that's n equals 2. How do you make an n equals 3 canon? Well, ignoring this line for now, you see, this particular canon, even if I didn't know it, even if it's not Frere Jacques, is still easier than writing a normal canon, than writing an arbitrary three-part canon in the following sense. Once I've reached this point, I have to make sure that voices 2 and 3 also make sense, just as voices 1 and 2 did, and as voice 1 and voice 3 make sense. But you see, this is exactly the same as that. So once I have a two-part canon here going, voices 2 and 3 automatically work with each other, provided that I made sure to use the same interval for voice 2 and 3 as I did for voice 1 and 2. Right? If I try to make a canon, okay, maybe I should use another piece of paper here. If I try to make a three-part canon where the first part does this, the second part does that as usual, but the third part enters on the fourth place instead of the third one, then suddenly it becomes extremely difficult because now this A, right, so having gone to this point, I have to find a C which will not just work with B, but will also work with A. And of course, it will make sense musically with B. And then having reached this point, D will have to work with C, and also with A, and also with B, because B and D are vertical here. So E will then have to satisfy three constraints. It will have to work with B, it will have to work with C, and it will have to work with D. And so I have to satisfy three conditions with just this one extra voice, and that's very hard. Whereas here we already have two voices that work with each other. We just have to find a third one that works with them. That's somewhat easier. And almost every three-part canon, be it Josquin or Shostakovich, is going to satisfy this property. If you don't believe me about Shostakovich writing three-part canons, listen carefully to the beginning of the great E minor piano trio, which starts. By the way, a piano trio is not three pianos. It's three instruments, one of which is a piano, one is violin, one of which is a cello. Which one of them do you think plays this? Well, because I asked you, it has to be the cello. Using this amazing, physics trick of artificial harmonics, where the cello is actually playing, playing this, but fingering exactly 1/4 of the string, likely above of the vibrating string, exactly 1/4 of the way to it, so it actually makes the fourth partial, which is to say 2 octaves above. Yeah, but this is very hard to do. And then the violin comes in 6 bars later. piano comes in way down here, and I don't have three hands, so and so forth. Listen to the whole thing played by the correct instruments rather than two hands on a good electric keyboard and one not so good bass singer. But the point is, it was 6 bars from cello to violin, and it was 6 bars from violin to piano. And for those of you who keep track of these things, it was also the same musical interval. So this was not entering on the same note. It was not B. It was a few notes higher. Sorry. We started here, then we went down a few octaves and up 2 notes, and then we go up another 2 octaves down and 2 more notes. So it's the same musical interval also, which means that even though the parts are so far apart, A and B, this version of A and B are still in the same relation to each other as this. And I know of only about 2 examples in music of this kind of canon. And one of them is a canon called Non Nobis Domine. It's been sung to many other texts. Also, it is not by the famous Renaissance composer William Byrd, although it's been attributed to Byrd. Nobody knows exactly who it's by. It even appears in Mozart's, as a piece no longer thought of as being by Mozart, but it has a Kircher number because Mozart evidently was so impressed by it that he copied it down. And Kircher didn't recognize the piece as some English Renaissance thing and attributed it to Mozart. And it goes like this. Non Nobis Domine is a psalm text that basically says, not to us, O God, but to you be glory given. Almost as if saying, this is almost as if the composer is, being humble and saying, this is a solution to this kind of task is not something that I can take credit for. God invented and gave me the grace of showing me this. And the tune is like this. Non nobis Domine, non nobis, sed Domini tua gloriam, sed Domini tua gloriam. And then it repeats, except you have the second part coming in, so this is A, B. So that's a 2-part canon. We know how to make one of these. Started A, B, C, and D only to come here. That's the Non Nobis canon. Not by William Byrd, but by one of his contemporaries. As I said, there's only one or two other canons I know that look like this, and at least the easiest one to refer to is the one from Brahms' Warum ist das Licht gegeben, which is another one of his vocal canons, but it comes also from a Massive canon that he wrote before. And just to illustrate another way that mathematical thinking can help, this is actually a 4-part canon where voices 1, 2, and 3 are roughly in the same configuration as they were before, but voice 4 is in the same connection to voice 3 as voice 1 was to voice 2. So here's the music. Parts. And in 4 parts, it sounds something like this. I said, this looks like a very complicated structure. One way that mathematicians would be tempted to think about this, which might actually be helpful here, it's really a two-part canon. It's a two-part canon, but it's a two-part canon not between single voices, but between pairs of voices. Here's one pair, and here's another pair. And they are encounter each other 3 units apart, and it just so happens that each one of these pairs is itself a canon at 1 unit apart. So, I mean, you still have to figure out that are things to make that work, but at least that gives you a framework for constructing it. Mathematically, by the way, there's yet another way of breaking it up this way, which is to regard, anybody see it? It's actually a two-part canon of two-part canons in 2 different ways. Because you can imagine that these are one of the pairs, etc. And then the other 2, you can see, are one unit behind them. So it's up to you whether you want to think about them as, you know, 2-part canons at a single time interval, 3 apart, or 3 time intervals, 1 apart. But anyway, it's a typical, somewhat, well, not atypical, it's an atypical example of a typical mathematical strategy of thinking of compound objects as single mathematical entities that can interact with themselves or with each other. So maybe I'll just finish, since I have like something like -3 minutes left, by giving some hint about, you know, what lies beyond canons. So canons are a very special case of what's known as invertible counterpoint, which is to say it's a counterpoint where you have 2 different lines of music, excuse me, A, B, C, D, etc., X, Y, Z, what comes after Z? T, alpha, ampersand, I don't know. But that can work with each other in more than one configuration. So maybe you have this would be first voice, the second voice with it, from the Brahms variations of the theme of Handel, I think it is, and the same thing, same voice, same counter melody. So and you might think, big deal, the same counter melody except it's below, but it's not in the same key. Instead of playing, I played. So you might think, oh. So it works in a, you know, that's what it's called double counterpoint at 12. So it shifts it by an octave and a fifth, and it works on either side. So that's an example of multiple counterpoint, and okay. And the 2 ideas can be combined. So, for example, people here have probably heard of the Goldberg variations. The Goldberg variations are a series of 30 variations that Bach wrote on the same tune, but basically the same harmonic progression. And so forth. And every third one of them is a canon. So there are 2 constraints here. It has to be our standard A, B, C, D, etc. But there is this additional constraint that the harmony that A makes with B and that B makes with C is a given chord, you know, harmony 1, harmony 2, which is constant through the whole piece. So there are fixed harmonies, and B and A, besides working with themselves, have to also realize H2 in some fashion. And then C and D will have to realize H4 in some fashion. And Bach usually gives himself a bit of help here by having a free baseline, you know, X, Y, Z, T, which is not usually constrained by which is not usually constrained by the canonic rule, and is simply there to make all of this amazing structure works. So variation of the canon is this, but with the bass. But then for the last one of this variation, we said I didn't really need all of this. The ninth variation, the 27th canon, without any need for a supporting part. So there are 30 of these variations. The 27th is the last canon. The 30th is sort of a mix-up of different canons and folk songs and a bunch of other wonderful things. Bach never, so the 30th variation is the last one. So the three-end variation is the canon at the interval of the end. So the sixth variation, the voice 2 came on the second note of the scale. This one, voice 2 came on the ninth note of the scale, etc. So the question is, how do I finish this talk? And usually I have this chorale player that I play based on this tune, which is, it's something like this, except that here the constraint is that every once in a while some standard tune like, Great Fortresses or God comes in and the canon has to match that also. I don't have enough time to do that, so I'll finish instead with what you might imagine could possibly an alternate universe might have been the 36th variation among the 30 Goldbergs. 36 is 3 times 12, so that means that the two voices have to be at the interval of 12 from each other, so first voice will be here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And they'll always be in this relation, and they'll also realize this Goldberg variation, this Goldberg theme. There is a major and a minor mode, and I'll only play the major mode, and then I'll open the floor for questions, etc. So.
So there must be some questions. Yes, Steve.
Your talk reminds me of a book I read several years ago about Goethe, Escher, and Bach by Hofstadter in Indiana. And in it, he talks about in the Bach view of cycling down this concept of self-reference.
Yeah.
Well, he also mentions these notes called Shepherd notes.
Shepherd notes.
Shepherd, right? Shepherd. Yeah. And when you go up the scale, you have two successive ones. I guess it'd be like having a one squared canon where you have A, B, C, D, and then right below it you have A, B, C, D with the A's underneath the A. But you vary the intensity of the note, the upper one, you soften it down, then you go up the scales, you get back where you started from. Can you play that? I've never heard that.
Oh dear. I think the
program haven't done that.
They say discretion is the better part of valor. I think the discreet answer is to say no. I mean, so this isn't exactly. I mean, it's as a canon, it's trivial, but the thing is that it's a way of playing. The piano is very long, but eventually it runs out of notes. And after 7 octaves, you can't play a scale anymore unless you want to, PDQ Bach. But if you imagine playing all of the octaves of the C major scale at once, well, imagine there are 7 octaves on the piano. I only have hands wide enough to reach 4 of them at once. But then if you imagine that somehow the upper voice is getting softer as the lower voice is coming in, So you can have the illusion, is this going to work? That you get sort of the idea, but this is really the kind of thing that you have to, well, you might be able to do it with extensive practice, which I haven't done, but it's very easy to program the computer to do this.
Right. And people who say I've heard it, it sounds really weird. Have you ever heard it?
Yeah, of course.
Okay.
It sounds weird, and I've even seen, you know, this Escher drawing, which has, which one am I talking about?
Stairs.
That's right, stairs, where you have people going down
Steps, yeah.
12 steps
Exactly.
and coming up where they started.
Right.
And so you can do that, but that's exactly what shepherd tones do. And so somebody made a computer animation where there is a fixed guy going down the 12 steps and winding up where it started. And because the shepherd tone, what I got here, the upper voice, and then you can sort of both hear the impossible endless descent and also see it here. So yes, that's been done. It's only distantly related to the kind of thing I'm doing.
But no, seriously, you also related to the mathematics, the concept of the inconsistencies of self-referencing. You know, you might have a theory that's both complete and consistent.
This isn't really a matter of self-reference. I mean, it's part of maybe the same circle or square of ideas, but it's really mathematically a quotient space. You take the real line and you declare that two points in it are equivalent if they're an integer number of octaves apart. So that you're basically wrapped up the real line into a circle. And then yes, you can keep going in one direction and wind up where you came back, and it's very common, you know, well-known feature of a circle or a clock that 12 hours later you're in the same place, even though time has progressed 12 hours. So it's this, you know, this mathematical topological notion of universal covering space, of a quotient space, and so forth. And this is a pictorial and musical representation of it, but it's not really a matter of this Gödelian self-reference. So I think that's about all I need to say about this here.
Other questions?
Yeah, here.
So given like kind of the algorithmic way of looking at this, do you think computers will ever be able to rival human composers?
Yes. When? Who knows? I mean, it used to be said that computer chess players will, you know, be equal with human, the world champion in 10 years, and it's always 10 years ahead. But that's happened, and it's been 10 years since then, and now the human chess players don't really understand what it is the computers are doing, but they're still, you know, beating them every time. It will take longer for music, to be sure, because it's not as, you know, things like which notes go with which notes, that you can already put on the computer. Things like what makes a reasonable musical shape is a bit hard to describe. But ultimately, you know, for chess, this is a, you know, there is a subjective, excuse me, there's an objective test, which is who gives checkmate. For music, it's a matter of, you know, moving the spirit of another human being, and that's somewhat harder to encode, especially when you don't have a human being. You know, you can't do an exhaustive search over a million possibilities, which is basically the way that chess machines work, because you don't have a human being there that can listen in a microsecond to each one of the million possibilities and tell which one of them is the best. So I'm sure it will be possible at some point, but the artificial intelligence folks aren't there yet. Composing canons by computers in principle an easy part of this, but for whatever reason the most convincing simulators of Chopin, of Mozart, and so forth haven't implemented it yet. They will soon, I'm sure.
Are there another questions? Another question?
Somebody up there, I saw.
All right, if not, let's thank Noam once again. Thanks very much for coming and drive safely.
Position.